welcome to day 6 challenge. Today we're gonna tackle the hardest question number 8 and 9. The answers are D, D, and C. Did you get them correct? Alright, let's look at the first one. Which of the following numbers is a perfect square? Okay, so looking at all the choices, I just find there's a pattern. So if you assume the first number on the numerator is n, and then you just have this pattern, n factorial times n plus 1 factorial divided by 2. And in order to make it a perfect square, I find I can rewrite n plus 1 factorial as n factorial times n plus 1, and then over 2. And the advantage of doing so is you already have a perfect square part that is n factorial squared. And what is left is n plus 1 over 2. In order to guarantee this is a perfect square, you need to make n plus 1 over 2 is also a perfect square. So at least this must be an integer, so n must be an odd number. The only options are 15 and 17. So let's try 15. 15 plus 1 over 2 is 8, not a perfect square. And 17 plus 1 over 2 is 9 of a perfect square. So that means when n is equal to 17, this is a perfect square. So we choose option D. Alright, let's go to question number 2. Points P and Q lie in a plane with PQ is equal to 8. How many locations for point R in this plane are there such that the triangle with vertices PQR is a right triangle with area 12 square units? Alright, so first of all, let me draw a line segment PQ. And in order to guarantee the area of this triangle is 12 square units. So if you consider PQ as the base, so the height must be 3, because 3 times 8 over 2 is 12. So now let me just draw two lines whose distance to PQ is exactly 3. And then I just know R must be some points on the two green lines. So the easiest way to construct a right triangle is if you consider PQ as one of the leg. And now you just need to, for example, you just need to draw a perpendicular line from P upwards or downwards. And you can easily find out the 2 points, let's say R1 and R2, both of them can make like a right triangle PQR with area 12. And the same thing is you can also draw a line passing through Q and find another 2 points, R3 and R4. And what if PQ is the hypotenuse? So the thing is you need to find out the point on the green line and then guarantee the angle PRQ is a right angle. So this time, if you know something about circle, just know that corresponding inscribe the angle to the diameter as a right angle. So this time, we can consider about the circle with diameter PQ like this. And then you just find some. You find some intersection of the circle and the two green lines, right? For example, let's call this point R5, and then if you connect P R5 and Q R5, and definitely this angle is a right angle, and also the area of this triangle is 12, and you can find 3 such points. So in total, we have, you can see we have another R6, you have R7, you have R8. So in total, we have 8 different locations for point R. Guarantee this is a right triangle with area 12. So we choose option D. Alright, let's go to the last question. The knights in a certain kingdom come in 2 colors. 2/7 of them are red, and the rest are blue. Furthermore, 1/6 of the knights are magical, and the fraction of red knights who are magical is 2 times the fraction of blue knights who are magical. So what is the fraction of red knights are magical? First of all, it's a typical fraction word problem. So we can thinking about assume some variables to better interpret this word problem. So first of all, I will assume the number of all the knights is x, and then I can represent the number of red knights as 2/7 x, and as for the blue ones, just like the rest of it, so 5/7 x. And we already know there is like a 2 times relationship. So if I assume the fraction of blue knights is, let's say, SM, and correspondingly the fraction of red knights is just 2M. And then we need to make good use of this fraction 1/6. So 1/6 of all the knights are magical. So let's do among all red knights, the magical ones are 2/7 x times 2m, and as for blue ones, we have 5/7 x times m, and it's equal to 1/6 of the knight, so 1/6 times x. So like on both sides, you can cancel out all the x's. And what is left is, for the left hand side, 2/7 times 2m, so 4/7m plus 5/7m, that is 9/7m, is equal to 1/6. So m is equal to 7/54. Alright, so we just know 7/54 of the blue knights are magical, and correspondingly 7/27 of red knights are magical. So we choose option C. Alright, that's all for today. See you next time.